TV. Today is episode 8, and it's Monday. And today we're talking about source and how in the in the circadian world. I told you I had three different segments about the circadian world, and now today, this week we're going to talk a little higher in the hierarchy. We're going to step up a little bit. I have a couple definition for you, and but basically it says the same thing, but now we're going to start using the terminology that goes with it. And today, what I wanted to talk about is uh, how we approach project uh, from residential to commercial, because there are two different scale and there's two different approach to it, and although it's the same basic, there's two different area we're going. So and it's not just a question of scaling the product line. As I told you, I'm working right now on putting some kits for residential so that you can start trying, you can start investing, you can start experimenting with the circadian lighting. But when we start talking about commercial space, it becomes something else. It becomes way more. We have larger space, we have higher space, we have different architectures, we have different contribution from daylight, from perhaps shadow, perhaps all kinds of things that needs to be monitored so that we have the right program and the right um, um, distribution in the space. We're also dealing, when we work in commercial, in an office or in a restaurant or in a hotel, we're dealing with way more people, meaning that we have to adapt to a bigger audience, and we have also to make sure that our system is working longer hours. As I told you, if you're very lucky and you work from home and you have your office at home, you can spend anywhere from 10 to 12 hours at home and experiment a lot of benefits from circadian lighting. Now, if you work in an office, or if you live in a hotel for a short stay, or if you go into a resort, or if you go to a very beautiful high-end restaurant, you'll have segment of this, but you want to make sure that it follows, your rhythm too. So the and what's happening is that since the system is going to work longer hour, but your interaction will be shorter. But it's important that it match with whatever you do. Now, the first question I have in mind, and that's why I did this episode today, is like, what kind of light source can scale efficiently? And as I was sharing with you last week in the previous episode, is that it is very, very difficult. I've been on it for probably now a month, and I've been gathering data, I've been analyzing, I've been buying a lot of prototype, a lot of sample. I've been talking to lighting manufacturers, and it is going to be a challenge. Uh, Not because they don't understand, they don't want, but because there's an adoption curve, and we're still ramping up. We're not at the plateau yet, and then it's not become a common item. And as I mentioned to you, also there's different kind of protocol that are working. Some are working with radio waves. Some are working with Wi-Fi. Some are working with Zigbee. Some are working with wires. Some have their own little protocol. Some work with Amazon. Some work with uh, uh, Apple. So everyone is pulling the blanket on their side, and at the end, it's slowing down because there's no such protocol that say, okay, guys, let's go in all one direction, and then let's all make some money. So right now, everybody is trying to pull the blanket on their side, and for us that try to implement and try to accelerate on giving you the data so you can experiment it, so you can have the benefits of it, and we can start scaling. It's very, very difficult. But, I mean, it's not impossible, right? I remember when when a long time ago, when the MR16 came into the world, was the same thing. The MR16 only had one beam spread, and there was only one type. It was a 50 watt, and that was it. And then we started playing with different power. Then we started working on different reflectors so that we could get tighter and tighter beam. Then we start working on the inside of the reflector so that we can and originally the MR16 came from the slide projector. So again, the technology took a while to adapt it, and by the time we had it down to an art, and even that, I remember having to test on my own. I was testing probably 4 different companies, 4 different beam spread, and having like a whole range of color, a whole range of beam spread, a whole range of spill light, which is like the light you don't want, but it's part of the beam because the way the reflector were built at that time. Anyway, the consistency was not there, and by the time the MR16 probably would have been consistent, the technology had flipped. We already had the LED coming in, and then the first thing you saw, and it was very funny because at the beginning, LED were stuffed in the glass shell of an MR16, and then they became the shape of an MR16, and then they became in metal, so they went from glass to plastic to metal, and now today they are what they are. But we still have the fixtures, we still have a need for this, but has manufacturer evolved and get better, now they're designing their own lighting engine. So they're not designing an MR16 anymore, that you can just replace the bulb and put another bulb. They're designing their own proprietary light engine, and then they, across their fixture, can replace any of that. They can mix and match, but you cannot use this light engine into a different fixture. So again, we're going into that this standardization, but it's just a growing pain, and it's been there forever, and I don't think it will change. But at least we are in a good tendency, is that now we can have more output with less power, and hopefully we'll start multiplying that and make it more and more efficient. So that's about the source. Now let's talk about the space, right? So we have different space in commercial. Like I said, we have different floors, right? We may have 10 floors. We may have an open lobby with a mezzanine. We have different zones, right? We have a zone that's at 30 feet in the air, and then we have some zones that are 20 feet. And then when you go deeper inside, then you have 12 feet. So again, different zone. And you may also have different occupants. You go to an hospital or you go to a hotel, you have the staff, you have the guests, you have the entertainment, you have all kinds of people interacting in different zones. Same thing for an office, same thing for a hospital, same thing for a theme park. So the light source, they must be very, very the light source, they have to have a stable output. As soon as we start shifting in colors and wattage and distribution, we're out. So stable output, control distribution, like I was telling you earlier, one of the problem with the incandescent source is that we had a lot of spill. It was very rare we could get a very nice sharp beam. We always had some spill around, and then we had to use mechanical lighting modulation tools such as louvers, snoot, or lens system with shutters and knife and all kinds of stuff to control all that spill and give us the lights that we want in the direction that we want. So, of course, all this is important because what's our goal when we do circadian lighting? Our goal is to get as much light into our little sensor. And I'm gonna introduce you a word, and I'm gonna give you the definition because I want you to start understanding in technical term. And the word is melanopic, MELANOPIC. Okay. And what does melanopic do is that it's the non-visual effect of the light that stimulate the melanopsin, okay, which is the photoresistor protein in the human eye that is regulating the circadian rhythm and the melatonin suppression. I'll repeat that. The non-visual effect of light that stimulate melanopsin, a photoreceptor protein in the human eye, regulating circadian rhythms and melatonin suppression. Now, 10,000 feet, what does that mean? It's exactly what I told you. Lighting on the ceiling doesn't reach our cell. It makes us see that we don't trip onto furniture or end up in a wall, but it does not much for our eyes. So what we're talking about is that we want to have the maximum light coming into our eyes and going in the back of our eyes and start doing the job. Telling everybody to wake up, go to bed, do this, do that, energize the body, nourish the cell, and all of that is done by having lights inside the eyes. Not looking at the light, not having light like this, light up, that doesn't contribute anything, but having light to our eyes. So this is the principle that I want you to understand. The word is not important. What's important is that you understand the concept that the light and the lux and all the what comes out of the fixture has to come in the eye. And of course, if you look at it, you'll have, but you're not going to walk all this all day because you're going to have first a sore neck, and second, it doesn't make any sense. So now we start to understand that in nature, when we have a sunrise, we have the light at us. At noon, we are having all this beautiful light bombarding us. And at sunset, we still have that sun, but now it had a beautiful color because now it's in the warm tone and until it goes to bed. And after that, it's out, right? So we can see that this little curve that we've been talking about, our body has to mimic this so that we regenerate ourselves, we regenerate our body, we take advantage of all this beautiful power that life is giving to us so that we're not sick, we have a better sleep, we have better everything. So we enhance our life. Because far from doing medical claim or anything like that, just being in that environment would make you feel better. And it's not like there's a big billboard say, oh, you feel better because you are doing circadian lighting. It has nothing to do with that. It's yourself, your body feeling it, and then, enjoying and being energized by it. Whew. So now let's try to understand how does that fit with this series and with the source, right? Because once we try to understand what does melanopic does to our body, now we can start to understand why we need sun, right? And also why we have to think about this at the beginning of the project, because it's going to make our life way easier. It's going to make us more alert and right? So all the benefits are going to come. But first, we got to start thinking about it. So how do we measure this? We measure the measure to see how much melanopic you have is measured in melanopic lux. And it's different in French and English. That's why my stuttering. But anyway, you understand the concept. Melanopic lux. So now, how do we measure that? Well, of course, there's different things to do, but we also need to have something to measure. If we don't have anything that's coming at us, there's nothing to measure. And if we do, then we can have. And as I showed you from the IAS-NA, from the CIE, the Commission International of Éclairage, or Lighting International Commission, what's happening is that there is some level that are that are required and that have been standardized. And we will, again, I'm working on some other project to make a little toolkit so that when we do project, either high-end residential or commercial or hospitality, we have a little brochure that help us. But for now, let's just say that you need some different levels. And like I said, this is we're looking at this very high, at the high level. And I don't want you to be lost in the decimals, because that's a war you'll never win. If you start to go at war for decimals with engineers and people that calculate all day, you'll never win. But if you let them do the work and give them the proper parameter, you will get what you need. So, of course, what is the basic thing? The basic thing is we want to have the highest level of melanopic lights during the day, right? Why? Because we want to support alertness and focus, right? Let's say we're doing hospitality. Well, it's the same thing. We want people to be balanced and be comfortable for activity. There's nothing worse coming out of a cave into the bright sun. It makes you very, very uncomfortable. But if the level inside is higher and you just have to adapt a little, then your comfort is going well. Plus, your circadian level, your circadian clock internal is not out of whack. You're not like, oh, I come from night directly to, noon daylight. No, there's a ramping up. So even if you go from inside and it goes down a little bit and then you rise outside, you're still within your circadian level. And I'm sorry, because you're never going to look space the way you looked at it before. And you'll become more aware, and you'll become more responsible, and you'll become more communicative. And, I thank you for that. But for now, let's keep enriching our knowledge, our basic knowledge of circadian levels, so that we can, you know, feel it for ourselves. So of course, when we do restaurant, well, it's we want to have a very low melanopic um, level in the evening, right? Why? We want to support the relaxation. We want to have the atmosphere, and the goal is also to have. We don't want all the light to be at their maximum. We want the place to be nice um, and healthy. And ideally, ideally, we would, you know, have the appropriate lighting for each function. So again, when we are in residential, when we are in hospitality, when we are in office, three different areas, right? We all need the same basic, but we have different application. We have different physical constraint. We have physical, also material palette. We have physical. We have psychological. We have different people. You know, and also whatever the task you're performing is also going to affect. You know how you're going to absorb all that light. So now let's talk about um, the subject that I picked today. Let's say we're talking, uh, and and I want to talk about this because without knowing, when I start to look at most of the project I did in my life, and I did lots and lots of large scale projects, I always managed uh, to to implement um, the light circadian program, right? I checked all the boxes except the programming. I didn't know about the circadian curve, but I always had downlights. I always had sconces. I always had table lamps. I always had lighting on the floor or on the baseboard. Why? Because for me, it was my way of revealing the architecture. It was my way of making this 3D space bigger, or making it, you know, more interesting on one side or on the other side, or give some depth, or, you know, just create this beautiful mystique look by having some knee below lighting and having seeing all these silhouette from people and furnitures and plants and so the mentality was always part of my design philosophy, even though I didn't have the the knowledge about the programming. Now let's look how how we would apply this. You know, so when we do a large space, let's say and I was talking about like a 50,000. I took the 50,000 square feet because it's about, you know, average project that I do. So we have 50,000 square feet. What's going to happen is that we want to have a uniformity of lights everywhere. So we want to be able to have a layer that's very uniform. We don't want to have, you know, like, uh, and I say we don't want to. It's not really true because we will have area. Let's say there's some kitchen. Let's say there's a workshop. Let's say there's, I don't know, an employee's room. So these areas that are not part of the experience may have some special zoning, but mostly the public space, we want something pretty uniform. And when I say uniform, is the mix of fixtures. Some downlights, some suspend, general diffuse, some directional, and then we have some below knee level. Now, one of the challenge that we will encounter is that when we do these kinds of projects, is that it's very rare that everything is at the same height. We have a beautiful lobby that may be open on 3 stories. We have a mezzanine that's open on 2 stories. Then we have, you know, elevator or little lounge that are open on 1 story. And then, so we have a variety of different heights that we have to deal with. And all those need to be taken in consideration because remember what we said earlier. We want to have a certain uniformity. So now, some of the lighting that comes from very high has to reach the same level as the one that doesn't come that high, and that does the one that is very low. So we got to work out a very an important lighting program. Now, the other thing that we're going to have to deal with and manage is the glare. We're going to have a very, very tight glare control. If we don't do that, what's going to happen is that our eyes, which is an iris, is that we're going to walk into a very glary area. So our eyes protect itself, shuts it down, and by the time we arrive into a place that it takes a while to unveil, so we always have this additional constraint to our eyes. And what happens when we add constraint to our eyes? Well, guess what? The amount of energy going in is different. So again, we're trying to get as much as we can to our captor, our registering system in the back of our eyes. So we don't want to start adding and closing and opening the iris and less and more lights and this and that. We want to make it very, very smooth. And also the last thing, which is not much psychological but has a lot to do with the physical, is we want also to be, concerned about the energy consumption. And energy consumption is something that I've been working with for the past, all my career. I started as an electrician, and in Quebec we were very, very, how could I say, aware of energy saving. So anything that could save energy, dimming, energy efficient product, control lighting switching, motion detector, all of that I'm very, very familiar with, and we had to because whatever, it was part of our program. But nowadays it becomes like everything becomes dissimulated. Before we had a fixture, it was 40 watt per tube times 4, it's 160 plus the ballast factor, and we would say, okay, this is 180 watt per fixture or 160, whatever. Now we say, oh, we have 13 watt fixtures. Well, guess what? That's just the LED. Then we have all the power that from the power supply that's in the fixtures. Then we have these little modules that we connect that are Wi-Fi, Zigbee, ba-ba-bee, ba-ba-boo, ba-ba-ba, to the fixtures, and they take a little bit too. So now our fixture that started at 11 watt now is probably 16, 17 watt. Again, one fixture, fine. Thousands of fixtures, we're adding for nothing. And not only we're adding for nothing, but we're multiplying by 2 or by 3 the amount of potential problems. So now, not only we have to watch for the LED viability, now we have to watch for the driver, and then we have to watch for the weakest component of all these components and these whatever Wi-Fi, Zigbee module that you add on to the fixtures, and for what, right? So, of course, energy consumption for me is a big battle horse. So, the more we scale, okay, the more we want to make sure we have a stable and very evenly distribution, that our system is adaptable to all the zones, and we can maintain that comfort, that visual comforts everywhere. And again, I started to tell you about PoE control, and that's where I come in and I come back, because now we're removing all that hardware out of the fixtures, and we're putting it in a server box, which is easily maintainable. We don't have to deal with power supply. We don't have to deal with frequency. We don't have to deal with radio wave everywhere for those people that are concerned about that. So, and also we have all our power is drove via Ethernet. So a little Cat 6 and that's it. That's how light is delivered, right? So within the PoE system, we have power, we have data, and we have control at each fixture. So, and if any problem comes, we come in, we unplug the fixture, plug a new fixture, done. We don't need to program anything. We don't need to do. It's all done at the terminal. So, when we're talking about maintenance, when we're talking about control, very precise. When we talk about real-time adjustment, it's very precise. And also, we have a central coordination. We don't have to go from one fixture to one fixture to one fixture to a repeater to another one and create a mesh, like a mesh of satellite around Earth, to make sure that our fixture gets radio control. We have one wire, and between A and B, if there's a problem, we run another wire and we're done. That's how it is and how easy it should be. But that's my little story about PoE lighting. Now let's talk about when we are in an office environment. And this is the thing that I hate the most. And I'm sorry if I tell you this, but one of the things that really, really turns me off is when we start talking about level of light. Because as we talk, for the past 8 episodes, source is, yes, about the amount of light that's coming out. But also, it is, there's an add-on factor, meaning that if you have a place and you're contributing with several different fixtures, you have to take that in consideration. Depending also if you have a general diffuse or directional and what direction it's oriented, you will have different readings. So when I start hearing numbers about lux and foot candle, and I get a little irritated because we hear the story of the numbers. And those numbers sometimes and most of the time don't reflect what's happening in the space. But I guess for somebody on their checklist, it has to be marked. So let's come back to office. Office, they say you need 300 to 500 millanapic lux at the desk. Good. And I'm going to stop there. 300 to 500, what it means that there's the fixtures that are going to touch your desk should be at least that. Now, do I have a meter? Do you need a meter? Does somebody's going to come with a meter to see? Probably never. If you cut your fingers, cut your hand, and your insurance company comes in and they say, we want to know exactly if we have 500, that's probably the worst case. But if you cut your finger on your desk, you have a serious problem other than the 300 to 500 millimetric lux. Unless you are, I don't know, you're sharpening knife or something like that. But then it's a workspace. It's not your desk, everyday desk in an office space. But as an example, and that's why I wanted to talk to you a little bit about it, because we can go into something like this very, very deep. But then what happens if you have 298? And what happens if you have 525? Right? So that's why my philosophy is that, okay, well, what's comfortable for you? Because as I grew older, my vision, I need more light. And my wife's laughing about my light in my office, but I don't care. I have enough. And and I work a lot with indirect light. That's why my ceiling, you see the light from the ceiling, and I mix cold and warm, and yeah, that's because I just use it to do this for now. And like I said, right now I'm working also on a smaller system for an office, and I want to show it to you live and da 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 da. But that's okay. So the most important thing to take out of this whole conversation is that you need to have sufficient lighting for yourself. If you don't have enough, if you don't feel that's enough, then it's not. And even if I tell you that you need between 300 and 500, if you don't have enough, you don't have enough, right? So let's take this as a convention. Whenever it's enough for you, that's it. I may have 500, then the screen, the computer screen may generate more, right? Or I have a table lamp. And now I also realize that my microphone is right there. So I'm not going to change it, but I'm just going to change the direction that I talk. So the challenge is also having light on our desk without glare. Why? Because again, our iris go up and down and go up and down. And what that does, that creates a delay in receiving the light. And, and of course, as I was telling you about energy, it is a very important part, but how much is it worth to you to be comfortable? So yes, in an office space, we're going to try to have some parameter. We're going to work within a range. We're going to make sure that nobody cuts their hand using or staple their fingers together. But most of the time, what we're going to try to do is make sure that you're comfortable, you have generous lighting that comes in absorbing, and then also that you are able to have less glare as possible. So we'll give you possibly the opportunity, because it's all controlled by keyboard, to adjust your light level for your space. If you don't have enough, you can increase. If you have too much, you can lower it down, and so forth. So those are benefits of having, a system that each fixture is controllable, and that they are very, very polyvalent. So on traditional system, I don't have to tell you, because probably most of you have that, is that an engineer did all the calculation, and the calculation ended up being one fixture every 8 feet square, and you have a place that is lit uniformly, and that's the end of it. There's no control, no dimming, no circadian effect, nothing. But now on a circadian system, what's happening is that now we can have the color of the fixtures are going to be taken care of, but maybe you can have a little bit more control over your zone. Like I said, if you are sensitive to light, or if you have light source or this and that, you may be able to dim it a little bit. And the system will also do that when it's a very bright sunny day. You'll probably increase the power so that you don't have this difference in contrast. And when it's a very moody day, it'll take it down a little bit so that you don't again. So all of that is done, by centralizing the control, having the effect of a system that you can control. And of course, the more flexible is your system, the better it is. So when we talk about a 50,000 square feet installation, we're more talking like an infrastructure, a lighting infrastructure. Why? Because we're going to deal with all kinds of parameters that are variable, all kinds of physical limitation, and also the occupancy. So we want to have some motion detector. If an area is empty, well, it should turn off, right? And again, yes, we can have all this added to a traditional system. We can add some module that we can control with our phone. We can add some motion sensor. We can add all kinds of little gadgets, but all we're doing is just adding on to our, a system that is um, not performing, and also we're just adding potential source of trouble. Why? Because every time you add a device, you are you are effect of the weakest part of that component. If they have one little resistor in that device that pops, that's it. The system is not doing what it's supposed to do. Well, the system may do what it's supposed, but that device is out of commission, and that's it. You're gone. And now you have to find which one. So again, it's a work in progress. And the idea is that we want to simplify the control, right? We want to support our design intent, meaning that if we need to control 3 fixtures, well, we control 3 fixtures. If we need to control 10 fixtures, then boom, we control 10 fixtures. If we need to control, one, we control one. We don't need a sensor at all the different fixtures. We don't need no. It's all, they all have their own circuit, and that's it. And let's say we need to add 5 fixtures. We just put them on, and that's it. We have, sometimes we can put an expander. Sometimes we just have to run a couple cables, and that's it. So when our projects are scaling beyond a single space, the source strategy becomes an important conversation. It's very important to start talking about, okay, what kind of source we're going to use, because this is where the conversation, and this is where the expansion, maintenance, and also the control is going to happen. Because yes, maybe we want to go with the cheapest fixtures, but how compatible is it with what we want to do? How much contribution these fixtures are doing? And I had this conversation not too long ago with an engineer, because he said, well, we're doing staircase, we put the cheapest fixtures. I said, do you know that the cheapest fixtures are in fact the most expensive fixtures? Why? Because they're 24/7 on, and also because they're made it with the cheapest component that are consuming the most energy. And he got it. So again, sometimes if we don't have this conversation, it's not going to happen. So basically, when the lighting is distributed intelligently, the performance of each different area becomes more consistent, right? And as soon as we can start this conversation in the commercial planning, the better we are, the faster we're gonna make it happen. So again, lighting at a large scale is not about more lights. It's about better distribution. And it's also, make sure that the source is designed for scaling. The source we're going to use can work in these different environments. And from room to room. Because the last thing we want is start to have inconsistency. So thank you very much. Tomorrow we're going to talk about fixtures. And hope you have a